Alright, thanks for not letting us see our tests.
I hate you.
You're mean.
They're a little angry.
I know it's more delicious.
Yeah. Underestimate it.
Alright, so the last part of approximation methods is trapezoids. So this is 5.5 trapezoid rule.
It is a concave up tangent approximation for how I feel right now.
Well, rectangles make a fairly good approximation, and they were the first approximation created.
Okay, let's approximate how high our hatred is right now.
It's easy to see that we're going to need a lot of them to provide a good estimate. We can find a better estimate in less time if we use trapezoids. If we were to partition the interval into subintervals like we did before, we can use each subinterval to create a trapezoid now, therefore connecting two functions. So this would be like the left, and this would be your right. So the height of the trapezoid would be the distance, or the width still, but the bases would be the y values. So the bases of the trapezoid are going to include the left and the right sum, and then we're having them to get like the average of the two heights. So that's what makes trapezoid better. Well, not all trapezoids might look like this. This one's the one we're going to be using, except for we're going to be taking it and rotating it on its side. So let's label this picture to match our area formula. So what we remember for trapezoid's area is base 1 and base 2 and height. So the formula for area is 1/2 height and then B1 plus B2. So what we're going to do for our formula is take a trapezoid and rotate it on its side. So we're going to orient it so the trapezoid is up and down, so that the width of the subinterval becomes the height of the trapezoid, and the bases become the heights of the curves. Does that make sense? That the bases are the heights of the curve, and the width is the height of the trapezoid. So like what we were filling in previously for delta x is now our h.
So if you pick like two different points that you know are on the graph,
That's what the heights of the bases are going to be.
Will following students please report to the office? Weston Wilchild, Dylan Sprouse, Seth Dunn, Seth Lesher, Caleb Gilman. The students please report to the office.
That's not a good crew.
It is
no,
not.
it's not. It's an AA meeting.
An AA meeting.
They weren't the senior cheerleaders.
Oh.
Hey,
I have to edit that out of the
Yeah,
recording.
No one in here is a senior cheerleader?
Nobody's ever gonna
yeah,
watch
but
this. None of them are ever.
not even last day.
True. She was the only one.
She didn't get drunk.
But
She
she knows.
doesn't count.
She knows she's not included.
All right. Using 4 trapezoids, approximate the area under the curve. So we're given a curve. What curve is this? This is a quadratic. Shift it up 1 unit. We are trying to approximate the area under the curve from 1 to 3. So we are approximating the area from 1 to 3. So we want to know what's the area under this curve between these 2 points. We're trying to find that blue region. So what we're going to do now to find that is find the height of the trapezoids. So height of a trapezoid will be B minus A divided by N still, where N is your subintervals. So it says I need 4 trapezoids. So we're going from 3 to 1 and dividing by 4. So my heights are half. So that means I need to know what the height of the trapezoid is at 1. I need to know what the height is at 1.5. I need to know what the height is at 2, 2.5, and 3. So go ahead, get out calculator and plug those in. These are going to be kind of gross on your quadratic. Maybe not one, but the other ones. That's why most of the AP questions are kind of like our examples on homework where they give you a table. So it's non-calculated.
So you can't integrate.
Correct.
So they're basically like, we're not allowing you to use what you're supposed to be using. We're not allowing you to use the correct way. Just so you can learn how to do this.
Is everybody able to get this? So essentially what we are doing now is summing up all of the rectangles. So we're summing up the area of a rectangle, which is 1/2, the height, which is also, and then adding the bases together. So base 1, or the height at 1, and 1.5, which is this first rectangle here, would be the 1 and the 1.25. And then we're going to add in the second rectangle. So the or trapezoid rather. So it starts where this one ends, and then it goes to 2. So formula is 1/2, height's 1/2, base 1 plus base 2. Add our third trapezoid. It starts where this one finishes, and then goes to 2.5. So formula is 1/2, height's 1/2, starts at 2, ends at 2.5. So the heights of the bases are 2 and 3.25.
Could you just add them all, like do 1/4?
We're going to get there. Now, again, that only works if the height of each rectangle, or the width of the base of the trapezoids rather, are identical. What else are you noticing about these trapezoids as I drew them in? What?
They're getting bigger.
They are getting bigger, but what else is duplicating beyond the 1/4? You notice happens
Plus
here and
one.
there, here and here, here and here. All the inside heights are doubled. So really what we could do is rewrite this by pulling out the half for the height, pulling out the half of the formula, and then saying, okay, it's the first height, which is 1, and all the inside face is double. Yep, so 2 times 1.25 plus 2 times 2 plus 2 times 3.25. Only one that doesn't double, again, like the first, is the last. You'd have to do that for just the middle one.
I thought that's what you were doing.
So you have 1/4. 1 plus 2 times 1.25 would become what? Yeah. 2 times 2 becomes 2 times 3.25. And 5. So 5 plus 6.5 is 11.5. 11.5 plus 4 becomes 15.5 plus 2.5. 18 plus 1. And they technically have 4.75 too. What's the actual area? What was the actual? Hey, did you say you found the actual? Did you say you found the actual?
It was 4.6.
Okay. So we are in overestimate. The graph is keep in mind.
Wait, I thought.
That's for linear approximation. That's the other direction. So we're going this way. That was going that way. Like, do you see why they would be opposites? Yeah.
And then if it's
That's
straight,
what I'm saying. Like, it
so
makes
it's like
sense, right?
That much more area.
Yeah.
So it goes like this, and all of that. A minute of deep breath.
I only have like
reduce
one more
stress.
yet.
Stress.
Let me finish, and then I'm going to give you yours.
Oh,
Unless it's like a dire emergency. I just.
Is it mercy?
I don't know.
That's funny.
I said if it's a dire emergency,
I
you
don't
can
know
go.
if
I'm not
it's
going to hold you.
How do you not know?
You're not a girl, boys.
I don't know if I'm ruining my $30 jeans or if I'm just paranoid.
So I said, you're not a girl.
All the girls are.
All the
We
girls
all
are
got
like,
it.
yeah, we understand.
That's why I said you can go.
I'll be fine.
All right, given the following information, use RAM with 4 subintervals. You missed, by the way, really bad. As indicated in the table to estimate the distance traveled. So, now, this is like the talk that we had for our homework. Are the intervals even? No. Let's go 0, 1, then 3, then 6, then 7. So we are using right RAM. So that means you are starting at the back side. Yep. So here's your rectangle 1, 2, 3, 4. So you see how I like kind of draw mini little rectangles when I make them? And then what I do is I think, okay, I'm using all the right sides. So even though I don't have a graph, what's the distance from 0 to 1? What's the distance from 1 to 3? 3 to 6? And 6 to 7? Okay? So now your rectangles are 1 times 2 plus 2 times 5 plus 3 times 10 plus 1 times 13. What would the units on this be?
Centimeters.
How'd you get that?
Because it's minutes, centimeters per minute, and so like,
All right. What do all of these represent?
distances.
Okay. They do. They represent the area under these curves, right? So what we're essentially doing is we're multiplying this 1, which is the time, times the velocity.
So they cancel out.
Yeah, so technically you're doing v of t times t, which velocity is centimeters, in this case, per minute, times time. So what happens is your minutes cancel. Just in case you have to come up with the units, I want you to know how to do it using that table. Well, I exploit the geometry. Okay, same idea, but now we're using the left ramp for this table. That's a pretty significant difference, is it not? 55 to 30? Granted, we're talking about a small distance, but we can see that the approximations in these cases are not the greatest. Let's look at a trapezoid. So again, you have a trapezoid. This is your B1 and your B2. You could always factor out the 1/2, but in the case of this problem with the widths being different, yeah. So this one has a height of 1, and you have to add the 1 plus 2. The second trapezoid would have a height of 2, and you have to add 2 plus 5. The third trapezoid would have a height of 3, and it's 5 plus 10. And then the last one has that height of 1, and it's 10 plus 13. So again, we get 85 for the sums of the inside. Half of 85 is 42.5. 42.5 sits pretty much in the middle of the other two. Okay, go ahead and take your break. When you come back, have a partner.